Alright, so now we're going to show you our second quality control objective, which was to light a green LED when VTAC is within plus or minus 10% of V command, what we want, and light a red LED when it's outside plus or minus 10%. So first we wanted to get 10% of V command. So we did that using a simple voltage divider. This is 9 kilo ohms and 1 kilo ohm. So that means right here at this node it should be 0.1 of V command. Then we ran that through a absolute value circuit, and the output absolute value of 0.1 of V command. Next we wanted to get the difference between VTAC and V command. So to do that we used a INA111, which is an instrumentation amplifier. It takes the difference between VTAC and V command. And so we have that difference at this node right here. And then we ran that through another absolute value circuit to get the absolute value of VTAC minus V command. Alright, so here's the corresponding part of our circuit with that circuit diagram. These are the two resistors that add up to 9 ohms and 1 ohm. And then we took the voltage out of that, which should be 0.1 of V command. And this is an absolute value circuit right here. And this is the output right here of absolute value of 0.1 of V command. Similarly, this is the INA111, which takes VTAC and V command and takes the difference, and we run that through an absolute value circuit, and here's the output. So right here, this is our circuit diagram with the comparators. It's pretty similar to our first one, so we're not going to go too much detail into them, but essentially green LED when it's within the plus or minus 10%, and a red LED down here when it's outside the plus or minus 10%. Alright, so the second set of LEDs right here is those two corresponding comparators and the LEDs. So right now it's within plus or minus 10% because I'm not changing the command voltage, so it's adjusted. The VTAC is adjusted. However, if I grab the motor arm, this makes VTAC not within plus or minus 10%, so the red LED will light. Alright, so now this is our third quality control circuit. This objective was to light a green LED when the motor current is less than 0.25 amps, and light a red LED when it's above 0.25 amps. Because of the resistor value in our current amp, we know that the current that's applied to the motor is 0.5 of the voltage going into the current amp, and also the voltage across the resistor of the current amp. They're both the same values because of op-amp rules. So if the current is 0.25 amps, we know that the voltage going in and the voltage across the resistor are 0.5 volts. So we basically want to compare 0.5 volts with the voltage that's actually going across the resistor in the current amp. So first we wanted to produce the 0.5 volts. So we took the positive 2.5 volts that we also put into the potentiometer and did a voltage divider with that. These two resistors added up in our circuit equal 4 kilo ohms and then a 1 kilo ohm. So that should output 0.5 volts. And this is velocity of the, or not velocity, voltage of the negative motor terminal. And we just ran that through an absolute value circuit to get the absolute value of the voltage of the negative motor terminal, which is also equal to the voltage across the 2 ohm resistor in the current amp, because it runs straight to ground. Alright, so this is the first part of what we just showed you. Right here at this node, it's positive 2.5 volts. So then we run it through these two resistors right here, which add up to 4 kilo ohms, and then the 1 kilo ohm to ground. And right here at this node, it should be 0.5 volts, which runs into where we want on our two comparators. And over here, this is the negative terminal of the motor. So we take that velocity, over here and run it through an absolute value circuit, and run that to here, and then split it in between the two terminals where we want them on the comparators. And again, our comparator circuits with this third objective. So it'll light a green LED when the voltage is less than 0.5 volts, which means that the current is less than 0.25 amps. And essentially the reverse for the red LED when it's greater than 0.5 volts or greater than 0.25 amps. Alright, and this is the corresponding part on our circuit board. And if I grab the motor arm, the motor will want to apply a current to get VTAC up to speed, because I'm limiting VTAC. So if I hold the motor arm, the red LED will light and the green LED will turn off. Alright, so we hope you learned a little bit about our circuit and our objectives of the project and how we accomplish them. Again, this is our motor velocity circuit for 530.241, and we hope you enjoyed the video, and we'll show you how it works again. So right now, motor velocity is positive, turn it to negative, and we can make these two LEDs go red by holding the motor arm. Alright, we hope you enjoyed. Thank you.